Hi, so I'm Caitlin and this is Ruby, and we've both been researching seaweed, specifically Fucus serratus, and today we're going to be discussing Ruby's project, which is investigating the resilience of Northeast Atlantic intertidal forests. So why do we research seaweed? So seaweed, as discussed in the videos, are very important habitats to an array of intertidal species. They provide food, refuge for these species, and also nursery habitats, helping them grow and thrive. They're also very important to protect our shores from wave exposure, preventing further coastal erosion. And as discussed, they also help store carbon, preventing further climate change. However, they are increasingly threatened by this climate change with warmer waters, and as Ruby will discuss, particularly in the south waters, they are starting to move their range to become further northward into the cooler climates. So climate change is warmer climates with warmer waters, but it's also more intense storm conditions and weather conditions, and this led to Ruby's question, which is how does the resilience of seaweed's forests vary and why? So I'll pass you to Ruby.
Thank you. So our experiment is investigating how seaweeds recover from large disturbance events like storms and heat waves. And to do this, we set up an experiment where we simulated one of these large disturbance events by removing the large seaweeds from 1 metre circular patches on rocky shores. And we did this in 3 treatment levels. We had a control where we removed no seaweed, 50% seaweed removal and a 100% seaweed removal. And what we expect to find is that the seaweed will recover slower in southern regions where they're facing these more warmer and extreme climates. So our study spans across 7 regions, from the Orkney Islands in the north of Scotland all the way down to Portugal and Spain in the Iberian Peninsula. And we also have 4 sites here in South Wales. And this has been a collaborative experiment. I've been working with local researchers in each of the regions. These photos show just some of the teams that are involved in this project, and also the extremes of fieldwork conditions that we face, from doing surveys after sunset in Orkney to the sunny Spain surveys. So what are we finding so far? Well, in most of the regions, including here in South Wales, we found that the seaweed is actually recovered really rapidly. However, we've seen a change in the seaweed species. So we started out with this cover of serrated wrack, and after the disturbance, we've now found the plots have been taken over by this other native species, the bladder wrack. And this is a sign of a healthy coastline. It means that there's multiple species available that offer a similar role, and when we lose one species, there's a similar species that could provide the same habitat and the same functions. But there is a key difference between these seaweed species, and it's in the name. Bladder wrack has air bladders. This allows the seaweed to float to the surface of the water where it can capture more light and grow more rapidly. So this is why it's taken over so quickly. But these air bladders actually have a negative impact as well. Because this seaweed is floating on the surface, this means it's more vulnerable to wave action and it can get dislodged by waves. So we expect to see that over time in regions such as South Wales, where we've seen this change in species, that the plots will naturally and gradually recover back to the original cover of serrated wrack. So it's good news for South Wales. However, there's one region in our study that really stood out as having a lack of resilience, and this is in Brittany. And you can see in these photos, even after 3 years, we haven't had any recovery of this large brown seaweeds. Instead, we've seen a shift to this smaller red seaweeds, which provides a different habitat but potentially less beneficial for some ecologically and commercially important species of fish and shellfish. So what me and Caitlin now been working on is looking at the drivers behind the lack of resilience in Brittany. So we're looking at impacts such as grazing and temperature to find out why the seaweed's not recovering in this region. I'd like to thank all of the collaborators in this experiment, everyone who's helped out with the fieldwork, and thank you all for listening.